Close to the Sun, a small planet holds secrets beyond our understanding. Mercury, the smallest and one of the most extreme planets, continues to surprise scientists with new and mysterious findings. Though it's tiny and scorched, Mercury has drawn attention for decades. Recent space missions have revealed unexpected phenomena, shaking old beliefs about this rocky world. One of the most shocking claims is the possibility that diamonds may exist on this blistering planet. The idea seems unlikely, but data suggests that extreme heat and pressure conditions could make it possible. And this is only the beginning. Beneath its surface, Mercury hides an interior too large and too strange for a planet of its size. Mercury's unusual core size has puzzled scientists for years. It's too big, as if something removed the outer layers of the planet early in its history. Unlike Earth, Mercury's core takes up over 80% of its volume. This makes it the most metal-rich planet in our solar system, a fact that still lacks a complete explanation. Why is Mercury so different? Was it once a larger planet that got stripped of its crust in a cosmic collision? To answer these questions, we must look at space exploration efforts that aim to uncover Mercury's secrets. The first mission to approach Mercury was NASA's Mariner 10, launched in 1973. Mariner 10 became the first spacecraft to fly by Mercury. It sent back images of a heavily cratered surface, much like Earth's moon. These close-up images revealed Mercury to be rugged, dry, and ancient. Scientists saw a world shaped by violent impacts and extreme conditions. But Mariner 10 also found something completely unexpected, a magnetic field. This was surprising because most small planets lose their magnetic fields over time. Mercury's strong magnetic field suggested that its core is still active. This challenged older beliefs that small planets like Mercury should be geologically dead. After Mariner 10, decades passed before Mercury received another visitor. Then came Messenger, launched by NASA in 2004. Unlike Mariner 10, Messenger was designed to orbit Mercury instead of just flying by. This allowed for detailed mapping, long-term observation, and data collection over many years. Messenger reached orbit in 2011 and began to transform our understanding of Mercury. It captured more than 200,000 images, some showing parts of the planet never seen before. One of Messenger's biggest discoveries was the high concentration of calcium and magnesium. These elements were especially rich on the dark side of Mercury. This strange chemical signature raised questions about how the planet formed. Was there volcanic activity, or did other processes bring these elements to the surface? Messenger also discovered that Mercury's magnetic field is stronger in the north than in the south. This imbalance suggests that its interior is far more complex than we imagined. Mercury's internal structure, according to Messenger's findings, doesn't follow the same rules as other rocky planets. The standard model for magnetic field generation, flowing liquid iron in the core, may not fully apply here. Messenger's data showed that Mercury is not just a dead rock in space. It's an active planet, with signs of geological evolution and unique inner dynamics. Another fascinating feature of Mercury is its extreme temperature range. During the day, surface temperatures can reach 430 degrees Celsius, 806 degrees Fahrenheit, hot enough to melt lead. But at night, without a thick atmosphere to retain heat, the temperature drops to 180 degrees Celsius, 292 degrees Fahrenheit. These are some of the most extreme temperature swings of any planet in our solar system. Despite these harsh conditions, volcanic features have been identified on Mercury's surface. In 2012, Messenger found pyroclastic deposits, signs of explosive volcanic eruptions. This discovery suggested that Mercury was once geologically active, possibly more so than once believed. It pushed scientists to rethink Mercury's history and how long it remained volcanically alive. In 2020, researchers made a groundbreaking announcement: the detection of water ice in Mercury's polar craters. These craters are permanently shadowed, making them cold enough to preserve ice. It sounds unbelievable. Ice on a planet so close to the Sun. But the crater's unique position keeps them in constant darkness, protecting the ice from melting. This discovery led to a new question. Could simple life forms ever survive in these cold refuges, just like extremophiles on Earth? In 2018, a new mission called Bepi Colombo launched toward Mercury. This is a joint mission between the European Space Agency, ESA, and Japan's JAXA. Bepi Colombo is scheduled to arrive at Mercury in 2025. It will provide fresh insight into the planet's chemical makeup, geological history, and magnetic behavior. With each mission, Mercury reveals more surprises. From its powerful magnetic field to the presence of water ice, the mysteries continue to grow. One of the most puzzling aspects of Mercury is its strange relationship between day and year. A year on Mercury is actually shorter than a single day on the planet. This is possible because Mercury orbits the Sun once every 88 Earth days. However, it takes 176 Earth days to rotate fully on its axis. That's one Mercurian day. As a result, a year on Mercury is half the length of a day. This causes bizarre effects for any observer on the surface. The Sun would appear to rise slowly, stop in the sky, then reverse direction briefly before setting again. This odd motion is due to Mercury's slow spin and fast orbit. Scientists say this is the result of tidal coupling with the Sun. Over billions of years, the Sun's gravitational pull slowed Mercury's rotation, but not enough to lock it completely. Instead, Mercury is in a 3-to-2 resonance. It spins 3 times for every 2 orbits around the Sun. This complex motion is one reason Mercury behaves so differently than other planets. In 2022, researchers found trapped nitrogen beneath Mercury's surface. This nitrogen might be the remains of an ancient atmosphere, now buried under intense heat and radiation. The presence of subsurface nitrogen is highly significant. It suggests that Mercury may have once had a thicker atmosphere, perhaps even a more stable climate. If Mercury had a denser atmosphere in the past, it could have retained heat and supported chemical reactions. This could change how we view its potential for habitability in ancient times. Not only was water ice found in the polar craters, but so were dark deposits. Scientists believe these may be organic compounds, the building blocks of life. These organics might have arrived from comets or asteroids. Such impacts could have deposited volatile materials, preserving them in the cold, dark craters. Mercury's polar regions, though limited in area, are stable environments that could hold these substances for billions of years. This makes them invaluable to planetary scientists studying the early solar system. The discovery of organic compounds on such an inhospitable planet is astonishing. It shows that ingredients for life may be more widespread than we once imagined. Organic molecules are fragile and usually don't survive extreme conditions. Yet Mercury's frozen shadows seem to have preserved them against all odds. Where did these organics come from? One theory is that they were delivered by cometary impacts early in Mercury's history. Comets, known to be rich in organics, may have bombarded Mercury during the late heavy bombardment. This would explain both the presence of water and the organic materials in these polar traps. Studying these compounds offers clues about how life's precursors spread across the solar system. It may help answer whether life could arise elsewhere, or how Earth received its own life-building elements. Mercury, though barren and scorching, now plays a central role in astrobiology research. This tiny planet could help us understand the distribution of organics and volatiles in the early days of our solar system. There is much more to uncover. Bepi Colombo's arrival in 2025 promises to unravel even deeper mysteries. Each layer of discovery brings new surprises and forces us to rethink our assumptions about how planets form and evolve. Mercury may be small, but its story is bigger than we ever expected. Subscribe to our channel and thanks for watching.